Tasks are interrelated, and to prevent from becoming a confusing morass, project team create a work breakdown structure, or WBS, which is a hierarchy of the tasks required to complete a project. The WBS for a large project is huge. It might entail hundreds or even thousands of tasks. Figure 10.16 shows the WBS for the system definition phase for a typical information system project. In this diagram, the overall task, system definition, is divided into define goal and scope, access visibility, plan project, and form project team. Each of those tasks is broken into smaller tasks until the work has been divided into small tasks that can be managed and estimated. 2. Estimate time and cost. It is exceedingly difficult to determine duration and labor requirement for many development tasks. Organizations take a variety of approaches to this challenge. One is to avoid schedule problem altogether and never develop system and software in-house. Instead, they license packages such as ERP system that include both business processes and information system component. As stated in Chapter 7, even if the vendor provides workable processes, those processes will need to be integrated into the business. However, the schedule risk of integration activities is far less than those for developing processes, program, databases, and other components. But what if no suitable packages exist? In this case, companies can admit the impossibility of scheduling a date for completion of entire system and take the best result that they can get. Only the loosest commitments are made regarding the date of complete and final system functionality. The third approach is to attempt to schedule the development project in spite of all of the difficulties. Several different estimation techniques can be used. If the project is similar to a past project, the schedule data from the past project can be used for planning. If there is no such past project, manager must make the best estimate they can. A project plan is a list of WBS tasks, arranged to account for task dependency with duration and resources applied. Some tasks cannot be started or finished until other tasks are completed. Given the dependencies, estimated for task duration and resource requirement are then applied to the WBS to form a project plan. Figure 10.17 shows the WBS as input to Microsoft project with task dependencies and duration defined. This display on the right, called a Gantt chart, shows task, date, and dependencies. The critical path is the sequence of activities that determine the earliest date by which the project can be completed. Reflect to the statement. The earliest date is the date determined by considering the longest paths through the network of activities. Paying attention to task dependencies, the planner will compress the task as much as possible. Those tasks that cannot be further compressed lie on the critical path. Microsoft Project and other project planning applications can readily identify critical path tasks. Figure 10.17 shows the tasks on the critical path in red. Using Microsoft Project or similar product, it is possible to assign personnel to tasks and to stipulate the percentage of time that each person devotes to the task. Figure 10.18 shows a Gantt chart for which this has been done. One can assign resources to the task and use Microsoft Project to detect and prevent two tasks from using the same resources. Resources costs can be assigned and summed as well. Managers can use critical paths to perform critical path analysis. First, note that if task is on the critical path and if that task runs late, the project will be late. Hence, the task on the critical path cannot be allowed to run late. If the project to be delivered on time. Second, tasks not on the critical path can run late to the point at which they would become part of the critical path. Hence, up to the point, resources can be taken from the non-critical path tasks to certain tasks on the critical path. Critical path analysis is the process by which project manager compress the schedule by moving resources, typically people, from non-critical path tasks onto critical path tasks. The project plan for the entire project results in a finish date and a total cost. The first response to a project plan is to attempt to reduce time and cost. Reduction can be made, but not out of the thin air. So, how can schedule and cost be responsibly reduced? By considering trade-off. Trade-off is a balancing of three critical factors: requirement, cost, and time. As shown in figure 10.19, we can trade off requirement against time and against cost. For example, if we make necklace simpler, it will take less time. If we eliminate the diamond and gem, it will be cheaper. The same trade-off exists in the construction of anything: houses, airplane interior, building, ship, furniture, and information system. The relationship between time and cost is more complicated. Normally, we can reduce time by increasing cost only to a point. For example, we can reduce the time it takes to produce a deck by hiring more laborers. At some point, however, there will be so many laborers working on the decks that they will get in one another way. And the time to finish the deck will actually increase. At some point, adding more people create these economies of scale. The situation that occur when adding more resources create inefficiencies. In software industry, we know Brooks law, named for the Fred Brooks, which states that adding more people to a late project make it later. This occurs in part because new team members need to be trained by existing team members, who must be take off productive tasks. In some projects, we can reduce costs by increasing time. If, for example, we are required to pay laborer time and a half for overtime, we can reduce costs by eliminating overtime. If finishing the deck by Friday requires overtime, then it may be cheaper to avoid overtime by completing the deck sometime next week. This trade-off is not always true, however. Extending the project interval means that we need to pay labor and overhead for a longer period. Then adding more time can also increase costs. Using trade-off, the WBS plan can be modified to shorten schedule or reduce costs, but they cannot reduce by management authorization only. Given the project plan and management endorsement and approval, the next stage is to do it. The final WBS plan is denoted as the baseline WBS. This baseline shows the planned tasks, dependencies, duration, and resource assignment. At any point in time, planning application can be used to determine whether the project is ahead or behind schedule and how the actual costs compare to baseline costs. However, nothing ever goes according to plan, and the larger the project and the longer the development interval, the more things will violate the plan. 4 critical factors need to be considered. 1. Coordination. 2. Diseconomies of scale. 3. Configuration control. And 4. Unexpected event. Development projects, especially large-scale projects, are usually organized into a variety of development groups that work independently. Coordinating the work of this independent group can be difficult, particularly if the group resides in different geographical locations of different countries. An accurate and complete WBS facilitates coordination, but no project ever proceeds exactly in accordance with WBS. Delays occur and unknown or unexpected dependencies develop among tasks. Another problem is diseconomies of scale. The number of possible interactions among team members rises exponentially with the number of team members. Ultimately, no matter how well managed a project is, these economies of scale will set in. Similar problems occur with the design, program code, database data, and other components. The team configuration control refers to a set of management policies, practice, and tools that developers use to maintain control over the project resources. Such resources include document, schedule, design, program code, test suite, and any other shared resource needed to complete the project. Configuration control is vital. A loss of control over a project configuration is so expensive and disruptive that it can result in termination for senior project managers. The last major challenge to a large-scale project management is unexpected event. The larger and longer the project, the greater the chance of disruption due to an anticipated event. Critical people can change company, even whole team have been known to pack up and join a competitor. A hurricane may destroy an office. A company may have a bad quarter and freeze hiring just as the project is staffing up. Technology will change. Competitor may do something that makes the project more or less important. Or the company may be sold and new management may change requirements and priorities. LDSC process is falling out of favor in the system development community primarily for two reasons. First, the nature of the SDLC denies what every experienced developer knows to be true. System requirements are fuzzy and always changing. They change because they need to be corrected. For example, users change their mind about what they want after they use part of the system. Business needs change of technology offer other possibilities. According to SDLC, progress goes in linear sequence from requirement to design to implementation. Sometimes it's called waterfall method because the assumption is that once you have finished a phase, you never go back. You go over the waterfall into the pool of the next stage. Requirements are done, then you do design. Design is done, then you implement. However, experience has shown that it just does not work that way. The second reason that the SDLC is falling out of favor is that it is very risky. The people for whom the system is being constructed cannot see what they have until the very end. At that point, if something is wrong, all the money and time has already been spent. Furthermore, what if, as frequently happens, the project runs out of money or time before it is completed. In short, the SDLC assumes that requirements do not change, which everyone knows is false, and it is very risky for the business that sponsor it. Numerous alternatives to the SDLC have been proposed, including rapid application development, the unified process, extreme programming, Scrum, and others. All of these techniques address the problem of the SDLC, and by all of them coalesces into agile development, which mean a development process that conforms to the principle in Figure 10.20. Scrum is an agile technique and conform to this principle. First, Scrum and other agile techniques expect and even welcome change. Given the nature of social system, aspect is not a surprise because systems are created to help organizations and people achieve their strategies. And the more the requirement change, the closer they come to facilitating strategies. And the more the requirement change, the result is better and more satisfying for both the user and the development team. Second, Scrum and other agile development processes are designed to frequently deliver a working version of some part of the product. Frequently mean 1 to 8 weeks, no longer. Unlike SDLC, agile technique deliver benefit early, and often the initial benefit might be small, but they are positive and increase throughout the process. With SDLC, no value is generated until the very end. Considering the time value of money, this characteristic alone makes agile techniques more desirable. The third principle in Figure 10.20 is that the development team will work closely with the customer until the project ends. Someone who knows the business requirement must be available to the development team and must be able and willing to clearly express, clarify, and elaborate on requirement. Also, customers need to be available to test evolving work product and provide guidance how well new features work. The fourth principle, rather than design the complete overall system at the beginning, only those portions of the design that are needed to complete the current work are done. Sometimes this is called just-in-time design. Designing in this way means that the design is constantly changing, and existing design may need to be revised, along with substantial revision to the work product produced so far. Finally, fifth principle, agile development methodologies are generic. They can be applied to the creation of business processes, information system, and application. They are applicable to other projects as well. Scrum is agile development technology developed by Jeff Sutherland, Jeff McKenna, and John Skamionatilis for a project at the eCell Corporation and extended by others over the past 15 years. Scrum is a rugby team and was first used for teamwork in a Harvard Business Review article written by Hirotaka Takeuchi and Ikujiro Nonaka. In rugby, Scrum is a gathering of a team into a circle to restart play after a foul or other interruption. Scrum is an agile development process with the characteristic shown in Figure 10.21. First, the process is driven a prioritized list of requirements that is created by the user and business sponsor of the new system. Second, Scrum work period can be as short as 1 week, but as with all agile processes, never longer than 8 weeks. 2 to 4 weeks is recommended. Each workday begins with a stand-up, which is a 15-minute meeting in which each team member states 1. What he or she has done in the past day. 2. What he or she will do in the coming day. 3. Any order that are blocking his or her progress. The purpose of the stand-up is to achieve accountability for team member progress and to give public forum for blocking factors. Oftentimes, one team member will have expertise to have a blocked team member resolve the blocking issue. Testing is done frequently, possibly many times per day. Sometimes the business owner of the project is involved in daily testing as well. In some cases, team members work in pair called pair programming. Minimal documentation is prepared, a working version of the requirements that were selected at the start of the Scrum period. At the end of the Scrum period, the working version of the product is delivered to the customer, who can, if desired, put it to use at that time, even in its not fully finished state. After the product is delivered, the team meets to evaluate its own process and to make changes as needed. Figure 10.22 summarizes the Scrum process. When are we done? Works continue in repeating cycle of Scrum period until one of 3 conditions is met. 1. The customer is satisfied with the product created and decides to accept work product even if some requirements are left unsatisfied. 2. The project runs out of time. 3. The project runs out of money. Unlike SDLC, if a Scrum project terminates because of time and budget limitation, the customer will have some useful result for the time and money expended. Scrum is distinguished from other agile development methodologies, in part by the way that it uses requirements to drive planning and scheduling. First, requirements are specified in a particular manner. One common format is to express requirement in terms of who does what and why. Given a requirement, the team meets to create tasks that must be accomplished to meet that requirement. In Figure 10.22, this work is done in the choose requirement to deliver activity. Figure 10.23 shows 8 tasks that need to be done to accomplish an example requirement. In the choose requirement to deliver activity, tasks for additional requirement might also be implemented in the Scrum period are created. Tasks are created in a meeting because team as a whole can iterate and allow members to give feedback. Scheduling tasks. As described so far, Scrum is a good idea, one of many agile processes that might be used. What makes Scrum particularly innovative, however, is the way that tasks are scheduled. According to Scrum process, once tasks are known for a given set of requirements, the next step is to assign each task a difficulty score called point. The easiest task gets score of 1. A task that will take 5 times longer is given a score of 5, and so on. Points are expressed in values from a sequence of integers known as Fibonacci sequence. For example, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. The number larger than 144 is meaningless. Tasks with such point score need to be subdivided into multiple requirements. A team work together, they will learn the total number of points of work they can accomplish each Scrum period. The term is called velocity. The team uses its velocity to determine how many requirements it can commit to accomplish in the next Scrum period. If you have not participated in software or system development, this process may sound like so much magical. However, it has two very important characteristics that make it so. First, it is a methodology that incorporates team iteration and feedback for scheduling and tasking, which, in a way, for a team to create something together that exceeds what they can do individually. Second, it provides a framework for process learning. As a team works more and more Scrum period together, it learns better and better how to assign points, and it learns more and more what its true velocity is. MIS in 2024. Process and system development will evolve in the next 10 years in 4 important ways. First, we will see a continuing focus on aligning business processes and information system with business strategy, goal, and objective. Second, computer system will be more easily changed and adapted to the future. Software vendors know that the key to their future growth is not having the single best solution, but rather on having a solution that is readily tailored to their customer idiosyncrasies or characteristics. Third, major change involved the cloud. Until very recently, when system development team wanted to build and test a new project, they would need to start a formal project and request funds to buy or lease development, computer, and communication infrastructure. Today, with elastic cloud computing, prototype and even finished system can be constructed in the cloud within very small hardware budgets. Fourth, between now and 2024, we will see the emergence of new software vendor business models. For example, the firm of Workout Studio in Minneapolis pays almost nothing in license fees for the full service operation application that it obtained from software as a service vendor Mindbody Inc. All of the credit card charges that the firm customer make are processed by Mindbody. This processing enables Mindbody to earn a small amount on every customer transaction. Mindbody supports more than 6,000 studios and trainers in the US. Its software is a veritable money machine. This is the end of chapter 10.